SinBuilder is an application for PC that allows you to design, configure, and keep in an easy and intuitive way your CCTV system based on graphic control unit UCG1R44. To start the application, we'll select Start, Programs, UCG SinBuilder, SinBuilder.x, or simply we'll click twice on the desktop direct access. After starting the UCG SinBuilder application, the starting working window will be shown with grey background. To start the assistant in a new project, we'll select File, New, or we'll click on the white paper icon. The new project dialog box will be shown. We choose a name for the project. We don't have to use special characters as backslash, slash, asterisk, questions, hashtag, dollars, %, and etc. In the project name, we'll name the new project Demo Line 1. This name will also be used as folder name where the whole project will be saved. We'll select the language in the language box. When pressing the button OK, the selection dialog of destination folder will be shown. We'll select the folder where the new project will be created and saved. Once pressed the button Save, a new project folder will be created, and the first window of the assistant will be shown, where we must specify the inputs and outputs number of the matrix system. We'll enter the camera inputs number of the installation. In this box we'll enter the monitor's number of the system. In case of not being configured, an error window will be shown. The maximum camera inputs number for the project is 300 and the maximum of monitors are 16. We must choose the concatenation topology, if necessary. The star concatenation will be used by default. It's possible to change the project language. For this project we'll use 16 cameras and 4 monitors. The camera inputs number can be expanded at any moment, but not the monitor's number and the language. Once the topology and the cameras and monitors number necessary for the project have been configured, we'll press the button Configure. The system will calculate the necessary equipment to build the project. In this case we'll use a 16 inputs and 4 outputs matrix and only one UCG1R44. We'll press the button Next to follow with the project assistant. The dialog where the monitor's arrangement connected to the UCG1R44 must be configured will be shown. With the existing folder menu in the same box, the default configuration will be modified. For this project we'll select the horizontal monitor's disposition. At the bottom side of the dialog, the matrices which have graphic control unit UCG1R44 or CSM consoles are shown. When pressing Next, the assistant will finish and there will be access to the working area. The first operation is to assign a background picture to the synoptic. The synoptics are created from files BMP, JPG, PNG, or GIF type, with a recommended size of 800x600 pixel or with a size relation of 4:3. For this project we'll use 5 synoptics based on files BMP that will have previously saved in graphics folder of the project. To assign a background picture to the synoptic, simply drag a picture file from its placement or select it through the dialog box of synoptic properties. A double click on the background will open the synoptic properties window. Clicking inside the box source file will accede to select the background picture. We'll select the picture file corresponding to the first synoptic and we'll press the button Open. The background picture will appear immediately. Now we can scale that picture proportionally or independently in horizontal or vertical. We'll modify the label generated by default, giving it the plain name. In this project the synoptic label will be main frontage. We'll mark this synoptic as the first one in the first synoptic box. We'll accept the properties by clicking OK. Next, we'll add the remaining synoptics provided for the project. We'll select the master matrix in the navigator window and pressing the right button we'll select Add Synoptic. We'll repeat the procedure, selecting the picture previously designed for the second synoptic. In this case, the pictures BMP have a dimension of 720 by 576 pixels. We'll adjust them to the desired size and we'll rename them as perimeter. Next we'll add the third synoptic. We'll adjust its size and position to center the picture in the working area. We'll add all synoptics of the project. Once the 5 synoptics of the project have been added, we'll select the corresponding main frontage. Clicking twice in its center, the properties dialog box will appear. We can select the background color of the area in the way that it doesn't cover the picture used for the background. Or maybe select the automatic option in order that the application generates the background that fits better to the picture. We'll verify the selection in the first synoptic box and we'll save the project. Next we'll put all the navigation points between the synoptics of the project. There are multiple solutions to solve the navigation between synoptics. A method that allows an agile navigation is to include in every synoptic references to the remaining synoptics. In the synoptic main frontage, we'll use graphic objects area type to navigate to the remaining synoptics. We'll place the object in the zone where we want to cover the area and clicking twice, the properties area window will be opened. We'll edit the label to identify it. This one will be to open the synoptic of the second floor. While the destination to a synoptic is not assigned, the object will remain crossed out in red color. We'll assign the destination to the synoptic second floor. Next we'll give dimensions to the object. Clicking on the object, it stays selected, showing a green color edge and squares in each corner. Clicking on the object and keeping pressed the right button of the mouse, we can move it of position. Pressing the right button of the mouse in one of the squares, we can modify the size of the object. To give it dimensions in a not proportional way, we'll keep pressing the caps key. We'll adjust the object until it covers the desired zone. In this case, the corresponding to the second floor. We'll add more objects area type to link with the other synoptics. Placing the mouse over the object, and clicking with the right button of the mouse, we have access to the area properties window. Once the area type objects have been placed, we'll modify them to make them transparent and make that the borders are not visible. In the perimetric synoptic, we'll only place an area type object that links with the main frontage synoptic. We'll make the necessary adjustments from the area properties box. First we'll assign the destination, selecting as destination the main frontage. Next we'll rename it, changing the label default name by the to main frontage 1. Next we'll take the border away, leaving unmarked the box show border. We'll adjust the size and the position of the object until getting the desired shape and position. And finally we'll make it transparent. In the ground floor synoptic, we also use area type objects, but we'll place them together on each other. We'll place here the object. We'll modify the background color and the border color. Once we have the desired color and border, we make 3 copies of the object, to have 4 objects with the same color and border. We place them aligned and equidistant and we edit them as we did before. We assign them the corresponding destination synoptic. We edit their label and we verify that the layer 3 is marked. We make this in each one of the area objects. To identify the areas, we'll use the text type objects. We'll select the text object and we'll place it everywhere of the synoptic. Clicking twice over, the dialog box of the text object properties will open. Clicking on the box font will accede to modify the type, the style and the size of the font. This time we'll select a font Arial Black, a bold type 1 and size 11. Next we'll adjust the text color, the thickness and the color of the border. In a graphic configurable object text type, the transparency properties of the text and the border can be configured. To finish we'll edit the text that will be visualized. If the option Updated Navigator is unmarked, the addition won't be updated in the navigator. We'll write MF to abbreviate main frontage. We'll verify that the layer 1 is marked and we'll press on the button OK to close the dialog. Once the text has been placed over the first area, we make 3 copies to have the same attribute. We'll edit and adjust all text labels to their position and we'll modify their size if necessary. Next we'll put the links to the synoptics in the graphic of the first floor. Here we'll use the object as synoptic. From the navigator, we'll open the tab of New Object. We'll select the object synoptic. We'll drag it until the synoptic. We'll make 3 copies and we'll place the objects aligned and equidistant. Clicking twice over each object, the properties box will be opened, where we'll assign the destination synoptic, and we'll edit the label. To identify the objects, we'll use the same texts of the ground floor synoptic. We'll select with the box the 4 texts and we'll copy them. We'll visualize the graphic of the first floor synoptic again, and we'll paste the copied texts. We'll place the texts and we'll change the red color to blue color, to harmonize with the objects. We only have to change the text F1 to GF. In the synoptic of the second floor, we only have placed an area object with a text that gives us access to the main frontage synoptic. To complete the navigation through the synoptics, we'll include an object exit. It's suitable to include in each one of the synoptics, 1 object exit at least. As in all objects, its size can be changed and restore the original size. The object exit has the only function of closing the synoptic where it is represented. We see how to edit and place a text object to the main frontage synoptic, only with a decorative purpose. It's possible to generate as many text objects as necessary. It's suitable to use text objects to identify every synoptic and to label parts or zones of the planes. These texts are complement to the graphic representation of the elements placed over the synoptics or planes. Next we'll place the camera and dome type objects and other objects of the project. From the project navigator, we'll select the perimetric synoptic and we'll open the New Objects tab. We'll select the dome object and we'll drag it to the synoptic, to the corresponding position. As all objects, we can adjust the size and the position. Clicking with the right button, a box is opened, where we can adjust the object transparency, delete it if necessary, restore the original size and accede to the dialog box of object properties. We'll make 3 copies of the dome object, with Control Copy, and 3 Control Paste, and we'll place them in the places where they represent the domes of the installation. In this case, we'll place the dome object in each one of the 4 corners of the fence that rounds the building to represent the real placement of the domes in the outside perimeter. We'll assign the corresponding physical input of the matrix or the matrix system to the dome object. In camera adjustments, we can edit the input identification text and adjust the video amplifier level for the input. We can also eliminate the load and activate the video failure detector of this particular input. By acceding to the dome object specific configuration, it's possible to select any of the dome brands of the different manufacturers with integrated protocol. Here it's possible to modify each one of the advanced configuration parameters of the dome input properties. It's also possible to edit the input type, or simply to mark it as hidden input. Once the object properties have been edited, we can clone its characteristics to other camera type objects, or edit each one separately. In the ground floor synoptic, we place 6 fixed camera objects. We drag the objects from the navigator to the synoptic. We place them and will resize them in their placements. We'll assign the corresponding input number to every object, and we'll edit the other camera object properties if necessary. At any moment, it's possible to visualize the assigned input to every object by pressing the key tabulator. Every graphic object placed in a synoptic has a singular value. In the graphic configurable object, camera, this singular value is the input number of the system that represents 2. In the first floor, and following the procedure, we'll place a new mobile type camera graphic object that has its particular characteristics. To complete the placement of the 16 cameras of the project, we'll place 2 fixed camera graphic objects more in the second floor. It will be necessary to place a new camera input of video recorder type in the ground floor. As we have all inputs of the project assigned, 4 dome type, 1 mobile type and 11 fixed type, we'll open the project assistant to increase the inputs number. We'll increase the camera inputs number to 32, so the matrix of the project becomes MM30, 32, 4. We already have the 32 inputs and we can assign the video recorder. We'll assign it to the input number 18 of the matrix. In the camera object VCR type properties, we can configure a recorder brand that has the protocols integrated or the recorder by default. Another configurable properties are the addressing, and inside the advanced configurations, it's possible to modify the input number and the multi-screen number of the video recorder. In the ground floor synoptic, we'll add a new object target type. The target type objects allow to switch 6 camera inputs simultaneously. This graphic configurable objects allowing the inputs configured as dome type to assign a preset number that will be called simultaneously with the camera switching. From the target dialog, there is access to configure this kind of graphic configurable objects. Six objective configuration boxes are available, where the camera numbers and the preset numbers that will be called in the moment of making the switching are selected. With the monitor folder menu, it's possible to configure which monitor each one of the cameras will be switched in, beginning in the monitor where the target is called. As in the other graphic configurable objects, it's possible to edit the label of the name that identifies the graphic configurable object in the navigator window. Finally, we'll place alarm special graphic configurable objects. The alarm graphic objects are available as different graphic representations, and each one in different sizes, because they are not scalable objects. They have a common interface to accede to their properties. In the Object Properties window, a list of the editable parameters appears. Device address. This value corresponds to the alarm input number of the video matrix. Synoptic destination. This value configures which synoptic will be shown automatically when this alarm input is activated. Monitor destination. In this value, has to be configured which monitor connected to a UCG1R44, the configured synoptic will be shown in. All special object properties must be configured with a value different from 0 for its right operation. To make other adjustments of the matrix system, you must accede to the application in CSM3000 by using the button placed in the tools bar. UCG SinBuilder will be minimized and the CSM3000 application will be shown with the configured current project. Any modification done from CSM3000 will be reflected in the project. If a camera type input is modified, the symbol will be modified according to its new configuration. This will also affect to the titles of the camera inputs, the communication protocols with domes and the remaining configurations. In no case, the project name used to open the CSM3000 must be modified. This would cause a fatal data unsynchronization for the project. We'll make the necessary adjustments, we'll save the changes and we'll close the CSM3000 application. UCG SinBuilder will appear again and it will be possible to continue working with the project. We'll take the blue background away from the main frontage synoptic and we'll put in white color. We'll save the project. Once the design and the configuration of the project have been finished, the generated files can be exported to be used in the graphic control unit UCG1R44. From the contextual menu of the icon master, we'll click with the right button on the icon. We'll select the option of the menu export to UCG. We'll choose the destination unit, where UCG SinBuilder will save the files for the UCG1R44. By default, only the removable units will be shown. The export process can be enlarged some minutes, depending the export time mostly on the efficiency of your PC. Once the message of export done appears, we'll accept. We'll save and close the project. Now we can load the configuration to the UCG1R44. To update the graphic control unit UCG1R44, just connect the pendrive with the project. With the pendrive connected, make a reset to the unit. When the UCG1R44 is restarted, the pendrive can be disconnected and then the USB receiver or the USB cable of the mouse can be connected again. To finish the process, it will be necessary to make a new reset. The graphic control unit will be completely operative with the new project.